Straw return. From the starts, hungry eco-cities paths to progress experiments.
Wheat feeds millions. But what becomes of the stems we leave behind? In northern Greece, Staramaki transforms wheat stems, an agricultural byproduct, into biodegradable drinking straws. Working with farmers, they have invested in specialized seed varieties that optimize both grain and stem quality. Since 2019, the social company has created work opportunities for vulnerable groups, opened new revenue streams for local farmers, and initiated ventures that support soil protection and regenerative agriculture, while offering a nature-based alternative to single-use plastics. Now, artist Isaac Monté enters the picture with a simple, radical question. Can the byproducts of Staramaki's process, trimmings, and rejected wheat stems regain value and become something entirely new? Where does the overlooked potential lie? Agriculture leaves vast underused biomass. Even sustainable manufacturing generates its own residues. Straw Return project set out to give this waste of waste a second life by turning it into premium materials that could replace plastics and reduce dependence on virgin resources. Straw Return addresses this disconnect, transforming what fields leave behind into materials that support both environmental restoration and economic opportunity, demonstrating how agricultural systems can close their own loops. Wheat stems, in their whole form, are naturally coated with a waterproof wax that resists binding. Yet, through over 100 material experiments, supported by AI analysis to rapidly test binding scenarios and refine natural formulations, the team discovered a fully natural binder to fuse shredded stems into a strong, lightweight matrix with promising properties, resulting in a 100% biodegradable material entirely free from synthetic additives. This new, circular carbon-storing material absorbs sound, resists fire, supports modest structural loads, and at the end of its life fully returns to the land, contributing to soil health, fostering biodiversity, and helping to combat desertification. Isaac's experimental practice meets Staramaki's local knowledge. Previous experiments with materials like stone paper, leak paper, and fruit peel composites laid groundwork. Straw Return goes further, yielding functional beauty that elevates natural materials to design statements. The research also extended into production. Sterilized boiled water from the process can be reused in the production of the binder. Waste heat from the ovens could support drying, and paper scraps from packaging may be incorporated into the mix. By redirecting these overlooked streams, Straw Return proves that regenerative design can work at every stage. The next step is scaling up. Partnerships across food production, manufacturing, architecture and design will bring larger prototypes like panels, lamps and acoustic installations into homes, workplaces and public spaces. Straw Return demonstrates a regenerative loop. What grows from the soil can return value at every stage, then decompose back into the earth, enriching it for the next harvest. These circular solutions enhance human well-being, strengthen resilience, and offer a blueprint for industries ready to turn their byproducts into assets.